Hello everyone, welcome back to the design of machine element tutorial. Yes, today we'll solve some more problems on the design of fastener and we'll wind up the design of fastener part. And from the next lecture, we'll deal with the design of rivets. I'll read out the problem. The cylinder head of the steam engine is subjected to a steam pressure of 0.7 Newton per mm square. Okay, the steam pressure is given and it is held in a position by means of the 12 bolts. Okay, in previous problem you are calculated the number of bolts or stud. In this problem they already given you the number of bolts, that is 12. Okay, next, a soft copper gasket is used to make the joint leak proof. Okay, a gasket is given which is made up of a copper for leak proof joint. The effective diameter of the cylinder is 300 mm, that is the capital D is mentioned in the problem. Find the size of the bolt, means the dimension of the bolt you have to find out here. So that stress in the bolt is not to exceed 100 megapascal. So stress is given as 100 megapascal. Okay. We'll start with the writing the given data first. Okay. So P, that is the pressure, is given, that is 0.7 Newton per mm square. N, that is the number of studs or bolts, they are given as 12. D is the effective diameter of the cylinder, is given as 300 mm. And of course, sigma T, that is the tensile stress, is given as 100 megapascal. Next, now the external load acting on the 12 bolts. Okay, because there are 12 bolts are given in the problem. Okay, which is equal to F equal to pi by 4 D square, that is the effective diameter, into P, that is the pressure acting. So we'll substitute the quantities. Pi by 4, of course, is a constant. D is 300 and P is 0.7. Okay. Next, which will get 49840 Newton. Fine. Now this is the force which will be acting on the 12 bolts. Okay. But we want the force which is acting on a single bolt. So what we have to do? We have to simply divide this number by 12. You will get the force acting on a single bolt. Okay, so this is what the force acting on a single bolt, which is equal to 4123 Newton. 4123 Newton. Fine. Next, initial load due to the tightening. Now this you have to calculate. The formula for that is Fi, that is initial load, equal to 2840 into D. Okay, so D is anyway not given. We have to find out D at the end of the problem. Okay, so keep this equation as it is. Okay, we cannot solve it further. Next, so total load will be equal to initial load plus load on the bolts, that is single bolt. Okay, we'll substitute the values now. Ft, that we have to find out. Fi is the load due to the initial tightening, this. Okay, 2840 into D plus K. K is what? K, we have having the soft copper gasket for leak proof joint, and for that K is equal to 0.5. Now this value you will get directly from the data handbook, into this F1 is 4123, which is nothing but the force acting on the single bolt. Okay, when you substitute, we'll get, this is what you will get. Ft equal to 2840D, this is a 4 due to the initial tensioning, and 2061.3. When you multiply this and this, you will get this. Okay, next. Okay, but we know that Ft equal to pi by 4 into dc square into sigma t. where DC, now this relation we already discussed in the previous class, DC equal to 0.8 times of D. We can write like this, okay? 5 by 4, 0.84 D square into sigma T, that is the tensile stress is 100 Newton per mm square. Next, sorry. So when you simplify this, you will get 55.4 D square. You will get in terms of D. Now what is next? Okay, still we have not got the value of D, correct? So again same logic you have to use. You have to see the equation number this and equation this. What you will find the common in this? You will find that the left hand sides are there equal. Okay, so what is next? If the left hand sides are equal, equate this side and this side. Okay, so how to get that? Just equate it and write down the equation. Okay, 55 into D square and 2840D plus 2061.5. So you take D terms on one side and remaining terms on other side. So you will get end up with the a quadratic equation 55.4 D square minus 2840D minus 2061.5. Okay, next what I did is I divided 55.4 throughout this equation, so that I will get D square minus 55.13D minus 37.21. Next, it is a simple quadratic equation. We can find out roots of the equation very easily with the help of your calculators. Okay, so what the value which I got is 52 mm. So that is the diameter of the stud. Therefore, the bolt size is M52. Now, this is what the solution we required, which is asked in the problem. That is the size of the bolt or size of the studs. I hope it is clear. Thank you.